Here we go. We're picking it up with number 27. Once again, you've got to make sure you draw and label your pictures. Be thorough with that. A fire is sighted due west of lookout A. So let's just start there. Give yourself some space, so don't start up against the edge. Okay, so we've got lookout A. And we want to go due west of that. So west is this way, and there's a lovely little fire. Okay, the bearing of the fire from lookout B, which we don't know where it is, it says 8.8 miles due south of A. Ooh, that's very helpful. Okay, so we're going to drop, boom, 8.8 miles, and that's going to be lookout B. Okay, so let's get a running start on that again. The bearing of the fire from lookout B, so we're from here to there, is 327 degrees, 327.9 degrees. So they're giving you the bearings where you start from north and you rotate all the way around. Okay, so if all of that is 327.9, basically, guys, what is 360 minus that? So 360 minus 327.9 is 32.1. I'm transposing my values. Okay, how far is the fire from B? Excuse me, I read that wrong. The fire from B, so that's it right there. So if this is the angle that we know, we have the adjacent side, we have the hypotenuse. That's going to be cosine. So we got cosine of the angle that we figured out because we wanted it to be acute. Cosine of 32.1 is equal to 8.8 over x. So once again, slide that thing over 1, cross multiply. We've got this right here. And then you're going to divide both sides by cosine of your angle. And I'm being lazy and I'm not writing it over there, but I guess y'all understand that this all goes. I have got 8.8 divided by cosine of 32.1 and 10 point, and what did it say, to the nearest tenth? So 10.4, and that would be miles. There you go. Alrighty, let's see here. Radio direction finders are set up at points A and B. They're 2.5 miles apart on an east-west line. Okay, so we got an east-west line. We're assuming they're in ABC order, okay, and that this is 2.50 miles apart. Okay, great. From A, it is found that the bearing of a signal from a transmitter, so we're trying to figure out where this transmitter is, but we're going from A, we're wanting to apply this, this angle. So that means go east this much from north. So I'm spinning this way, and that's telling me that this little part right in there is 36 degrees and 20 seconds. So quite honestly, I need the other part. I'm going to need 90 minus that to get any work done. So this is my transmitter up here. And then it says from B, we need to go west from north. Okay, so you're going to start at north. You're going to go in the west direction, and that this little lovely space right here is 53 degrees 40 minutes. Okay, it wants to find the distance of the transmitter from B. So this is what we're looking for. We need to get in this triangle. First of all, you got to prove that it's a right triangle, which is not going to be too hard, because if you put 36 degrees 20 minutes with this one, see, 36 and 53 is going to give you a lovely 89. Here, let's back up and do this, because remember, 36, 20, it's been a little while since we went through this. That is a whole degree, remember? And this is 89, so you put those two together, it is 90. So these two, this is the complement, this is 53, 40. And my pen's a little big for this. Let's shrink it down some. 36, that did not work, did it? They basically swap places because you're doing the complement of it. So if these two add to 90, that's really 90. I didn't draw it that way, but it's what it's supposed to be. So if that's the case, and that's our 90-degree angle, that makes this the hypotenuse, okay? So my picture may be ugly, but that's the way it works. So you can pick whichever angle you want to work from. I particularly like sine, so I'm going to go with the opposite idea. So I'm going to start with here, and my opposite side is x, and My hypotenuse is, I almost lost him. There's my 2.5 that they told me that it was a part. So my picture is kind of cluttered. Sine of 53 degrees, 40 minutes is, opposite that is what I want, x. My hypotenuse is 2.5. I guess let's put the 0. Now, if you put that over 1 and you cross multiply, you've got 2.50 sine 53, 40 minutes, and it should all work. Just remember that 2.5 sine 53 plus 40 divided by 60, or you could just do 2/3. That's going to give you, we want to go to the nearest hundredth of a mile, so we need to go 2.01 miles. Okay. If you give yourself more room to draw your picture, it works a lot better. Okay. Whew. That was the tough ones. So convert the angle to radians. Now remember, the one that you want is what's going to go on your little conversion fraction or conversion ratio. We're using the fact that over here, 180 degrees is in the same position as pi. So you can turn that whichever way you want, but these two are equivalent, so it's like multiplying by 1. So you're not changing the value, you're changing the way it looks. We want radians, we're going to put radians in the top, we're going to put degrees then in the bottom. So if you're going to just change this, and it wants it in multiples of pi, that means leave pi in your answer. So think about it like this. You want to use your little calculator and do the math inversion, which I do believe, grab one of those smaller calculators. I don't normally use these, but you would do 252 divided by 180. You're going to hit second, PRB, enter. Then you're going to hit second, ABC, enter. And that's going to give you 7/5. Then you've got to remember, I never typed in a pi, so the pi goes in the top of that. There's your answer. But you have to remember your sequence of buttons because it's different from the graphing calculator, and you can't use the graphing calculator. So convert the radian measures to degrees. That means we want degrees on top. So we're going to put 180 on top, and we're going to put pi on bottom. The beautiful thing here is that your pi's cancel. Let's just use a different word. Reduce. They reduce. Because they don't go to 0, they go to 1. Now we've got, it doesn't matter how you type it. You can do 9 times 180 divided by 2, or you can do 9/2 times 180. Order really doesn't matter. You just need to multiply it out and get your answer of 810. Okay, find the exact function value. So we're doing basically what we did earlier. We just happen to be doing it with radians. Now, if you absolutely hate radians, you can take yourself a moment and do what we just did and come over here and you can mumble the entire time if you want to, and convert this to degrees. And when you convert it to degrees, you should get 120, and you're right back to where we were earlier in the review. But I'm hoping you guys know that this is pi, and so 2/3 pi is going to give you a reference angle of pi over 3, and pi over 3 is the exact same thing as 60 degrees. That's the way I'd rather you think about it. Opposite the 60 is going to be square root of 3. Adjacent is going to be -1 because you went left. Hypotenuse is 2. Cosine then is adjacent over hypotenuse, and you're done. Okay? Now cotangent of -11 pi over 6. So, I mean, it's just easier to approach it and just go ahead and bite the bullet and do it. Negative just means we're rotating this way. That is almost 12 pi over 6, which would be 2 pi. So almost full circle. You missed going backwards, full circle, by pi over 6. So if this value right here is pi over 6, it's your reference angle, that's the same thing as 30 degrees. Opposite 30 is 1, adjacent square root of 2, hypotenuse is 2. You want cotangent. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is going to be adjacent over opposite. So square root of 3 over 1, or just square root of 3. Okay, now we have cosecant of 3 pi over 4. Well, that's not quite 1 whole pi. You missed it by a fourth. Here's pi, here's 3 pi over 4. And like we said, you missed it by a fourth. That's 1/4 pi, which is the same thing as 45 degrees. So 45 degrees, we haven't done it a whole lot in the review. The legs are 1. The hypotenuse is square root of 2, but we went left, so you got to put a negative. Now cosecant is the reciprocal of sine. So if we do sine, we got opposite over hypotenuse, but we need to flip that upside down. Hypotenuse over opposite, which is going to be square root of 2. All right. Find the length of an arc intercepted by a central angle theta in a circle of radius r. Round your answer to 1 decimal place. All right. This is your solar formula. That's just the easiest way to remember it. Okay, so arc length is S. There's your angle, and there's your radius. The big thing that you have to remember is it must be in radians. It's not going to work if it's not radians. So if they give you something that's not radians, your job is to convert. And look at there. They gave you degrees. Sneaky, sneaky. That's not a big deal. You can go straight to your problem. So your arc length is going to be your angle, which is 24. But let's go ahead and convert it right here, right now. We're going to do it just like that. And then our radius is 119.94. Now, do you see that your radius is decimal? That gives you permission. This right here gives you permission to just type everything in and go 100% decimal. That means this pi needs to be typed in. So we're going to type 24 times, and then just go ahead and pull it up. Pi divided by 180 times 119.94. And you're going to get 50 point, what did it say to 1 decimal place? 50.2. There you go. Okay, assume that the cities lie on the same north-south line and that the radius of the Earth is 6,400. Okay, that's important. Don't forget that. That's going to be your R. So find the distance in kilometers between city A and city B. Now notice that this one is north and this one is north. That means that, think about it, if you've got the good old Earth and north, you're just going to subtract those two. Be careful lest they give you a problem that says, hey, this guy is north and this guy is south. Then you would take this and add it to that. All right? So be very mindful of whether or not it says north or south. If they're different, you got to add. If they're the same, you got to subtract. So what we're interested in is, whoops, would help if I got my pen. We want the arc length because that's going to tell the portion of the Earth they are apart. And again, our angle, we need to subtract. 24 minus 16 is 8. We've got to convert Mr. Degrees to radians. And then we're going to multiply it times our radius, which is the radius of the Earth. Now it's just about typing it in. 8 pi divided by 180 times 6,400. And I got 893 point, what did it say, to the nearest whole number? Oops. Since it's a 0.6, I need to go to 94. Okay, there we go. All right, we're going to stop here and pick it up next time with the next video.